got the velocity here of particle, and it says show that it comes to rest when t is 3, or first comes to rest when t is 3. So when it comes to rest, of course, if you think about it, when it comes to rest, the velocity be 0, isn't it? Okay, because it comes to a stop. So we can put this equal to 0. We've got a quadratic equation, haven't we, which we could solve. Now, before we solve it, have a look if there's any common factors, and we can see 3 goes into it, so that makes it a lot easier if we divide by 3. Okay, so we get that. And if we solve it then, okay, we get those two factors there. So t minus 3 is 0, or t minus 5 is 0. So that means t is 3, or t is 5. Okay, so you can see that the first time it comes to rest is when t is 3. So it first comes to rest when t is equal to 3. Okay, it also comes to rest when t is equal to 5 as well. That's the first time it comes to rest. So part B then, it says find an expression for the acceleration. Now remember, acceleration is the rate of change of velocity. So it's how velocity changes with respect to time. So you just got to differentiate this here. So we get 6t, don't we, when you bring that 2 down, minus 24. Okay, so nice and simple there. Part C then, find an expression for the displacement. Well, remember, displacement, okay, or the rate of change of displacement is the velocity. So instead of writing velocity like that, we could write velocity as dr by dt. Yeah, so that's what velocity is, the rate of change of displacement. Now, if we integrate the velocity, we'll get the displacement. So if we integrate it, we get r. So we're just going to integrate all of this here. Okay, so we get 3t, increase the power, and divide by that new power. Plus then a constant at the end. So this becomes t cubed minus 12t squared plus 45t plus c. Now, we need to work out what the constant is before we finish the question. But it does say, doesn't it, the particle is projected from the origin O, so it moves along the x-axis. So because it's projected from the origin O, okay, we could say when t is 0, r is also going to be 0 because it's projected at the start from the origin. So its displacement at the start will be 0. So therefore, 0, so r will be when t is 0, so you get 0 equal to c. So your constant is simply 0. So you get this then as my displacement, expression for my displacement. Part D then, it says find the distance travelled by the particle in the first 3 seconds of its motion. Okay, well, so when t is equal to 3, okay, r will equal to 3 cubed minus 12 times 3 squared plus 45 times 3, okay. That comes out to be 54, if I've done that right. I think I've typed that in right. Okay, yeah. So that's so far as travel, or that's its displacement after 54 meters, okay. So remember now they're asking for the distance that it's travelled, and I'm happy that it is travelled that distance there, 54 meters. But bear in mind, at the start of the question, it says when t is 3, it comes to rest. So literally, in the first 3 seconds, it's travelled 54 meters. Then it comes to a stop. Okay, so let's think about what happens then when it comes to a stop. Okay, it comes to an instantaneous stop, and then it keeps travelling again. Let's have a look then for part E, when t is 4. So r is equal to, let's put that in, So it's asking for the distance travelled when t is 4, so an extra second. So I type that into my calculator. So I can just go back on the replay button and change everything to a 4. It comes out to be 52 meters. Now, you've got to think logically about this. Part D, in the first 3 seconds, it had travelled 54 meters. So now it's saying how much has it travelled? What's the distance it's travelled after 4 seconds? Well, it can't be less, can't it? You see what I mean? It can't be travelling less distance if it's over an extra second. It should be more. The distance should be more. However, we were told, weren't we, when t is 3, it came to a stop. Okay? And the other thing you must remember as well is that this is representing displacement. So what's actually happening is, right, here's my origin. It's travelled 54 meters in the first 3 seconds. Okay? When t is 3 seconds, it's travelled there, but it comes to a stop, doesn't it? Instantaneous stop. What happens then is that it actually reverses direction. Okay? It reverses direction and it goes this way. So a second later, it's at 52 meters. So when t is 3, it's got to 54 meters. That's the distance it's travelled. But when t is 4, displacement is 52 meters. Now I kind of got an idea that it's reverse direction because it came to a stop, didn't it? It came to a stop, which often means it's going to turn around. Okay? So, after 4 seconds, its displacement is 52 meters. In terms of its distance travelled, okay, you've got to think about this logically. It's travelled 54 meters, isn't it, already after 3 seconds, and then in the following seconds it's travelled 2 meters, so the total distance will be 54 for the first 3 seconds, plus then that extra 2 meters, so we get 56 meters. That's what we're looking for in terms of the distance travelled. The displacement is 52 meters, but remember, displacement is how far we are from the origin, but the distance travelled, okay, is the 54 in the first 3 seconds, plus then the extra 2 meters there, which gives me 56 meters.